Assalamualaikum. Hi, my name is Adil Batia. So our group will present our topic volumetric analysis of fruit juice titration. So this is our group member. In this presentation, there will be introduction, theory, methodology, example of results, and conclusion. Titration is a key technique in volumetric analysis that can be effectively applied to the analysis of fruit juice. Titration is a fundamental technique within the volumetric analysis, a widely employed method in chemistry for quantitative analysis. It involves the controlled addition of a solution with a known concentration, known as the titrant, to react completely with a substance of interest. Titration also an essential tool used to determine the concentration of a solute, identify unknown substance, and quantify chemical reactions with accuracy and precision. Fruit juice are popular beverage consumed worldwide, and their quality and composition play a crucial role in consumer satisfaction and health considerations. Titration offers a reliable and precise method to determine various components in fruit juice, such as acidity, vitamin C content, and sugar concentration, providing valuable insights into their nutritional value and taste profile.
Hi, my name is Fatin. So today I will introduce the theory of volumetric analysis. What is volumetric analysis? Volumetric analysis is a chemical analytical procedure based on measurement of volumes of reaction in solution. It uses titration to determine the concentration of a solution by carefully measuring the volume of one solution needed to react with another. In this process, a measured volume of a standard solution, the titrant is added from a burette to the solution of unknown concentration. When the two substances are present in a set stoichiometric ratio, the reaction is said to have reached the equivalence point. These are the common titrations, which are redox titration, complexometric titration, and acid-base titration. Okay, now let's move to acid-base titration concept. Okay, so firstly, it involves a neutralization of reaction in which an acid is reacted with an equivalent amount of base. Secondly, titrant curve pH of the solution versus volume of titrant added. The third one is titrant is usually strong standard acid or strong base. After that, endpoint is a point when the reaction is completed by changes in the color of the solution. And the last one is equivalent point is the point of stoichiometric equivalence between the analyte and the reagent. Did you know that fruit juice contains both citric acid and ascorbic acid? Citric acid is used as a natural preservative and provides a sour taste. Fruit juice are often used as example of fruit acid. The citric acid content of a lemon and orange juice can be determined through a titration of the juice. The experiment will be conducted to determine the amount of citric acid present in the fruit juice. This process involves a certain volume of juice having a base of a known concentration added to it until a point is reached where all the acid in the juice is neutralized. Juice made from lemons is the most acidic. It rates between 2.0 and 2.8 on the pH scale, while the pH of the orange juice is between 3.3 and 4.1 depending on the variety of the fruit.
Hi, my name is Tuan Zafira. So now I will present about methodology. In this experiment, apparatus and chemicals that we use is beaker, conical flask, fruit juice which is orange and lemonade, natrium hydroxide solution, retort stand, burette, dropper, 20 ml pipettes, distilled water, and phenolphthalein as indicator. The first step in this experiment is 10 ml of the orange juice was pipetted into conical flask. Second is 10 ml of distilled water added in the conical flask. And step 3, 2 to 3 drops of phenolphthalein was added as indicator. The first step is the orange juice in the conical flask was titrated with the natrium hydroxide solution from the burette slowly while shaking the flask until the indicator changed color. Next, step 2 and 3 was repeated 3 more times. Step 6 is the endpoint of the titration was recorded. Step 7, step 1 to 5 was repeated using lemonade juice. And the last step is the mass of citric acid in the fruit juice was calculated. So now, let's watch this video.
Hi, my name is Khadijah Noor and I would like to explain about the example of the results. And this is the example of results for orange juice titration and lemonade juice titration. The data show for the raw orange juice titration, we got the final burette reading and volume sodium hydroxide used is 20 ml. And then, for the first actual experiment, we got 90.8 ml for the final burette reading and volume sodium hydroxide used. For the second actual experiment, we got 90.5 ml for final burette reading and volume sodium hydroxide used. And lastly, we got 90.8 ml for final burette reading and volume sodium hydroxide used. And the total average for orange juice titration is 90.7 ml. For the lemonade fruit juice titration, the raw data for the experiment is 23 ml for the final burette reading and volume sodium hydroxide used. And then, for the first actual experiment, we got 22.8 ml for the final burette reading and volume sodium hydroxide used. For the second actual experiment, we got 22.5 ml final burette reading and volume sodium hydroxide used. And lastly, we got 23.2 ml for the final burette reading and volume sodium hydroxide used. The total average for lemonade juice titration is 22.8 ml. The reaction between citric acid and sodium hydroxide will be produced sodium citrate and water. And beside me show the balance equation for the reaction. From the results, we can get the exact amount of citric acid that is contained in the orange and lemonade juice by using the formula mass equals to moles times molecular weight. And the result that we get from using the formula is 0.127 gram for orange juice and 0.146 gram for the lemonade juice. And for the discussion, by using this method, we can determine which of the solution is more acidic and less acidic. Orange juice and lemonade juice are used as sample for this experiment. The reaction between citric acid and sodium hydroxide will form sodium citrate and water. We also have determined the amount of sodium hydroxide that is needed to neutralize the acid. The average of sodium hydroxide used to neutralize both orange and lemonade juice are 90.7 ml and 22.8 ml respectively. It shows that the volume of sodium hydroxide used for lemonade titration is higher than orange juice.
It's me again, Fatin. I will continue with the discussion. It means that lemonade is more acidic and its pH is lower than orange juice. We have figured out the total mass of orange and the lemonade juice solution that we use in this experiment. For orange, the total mass is 0.127 gram. The total mass for lemonade is 0.146 gram. There are some precautions we must follow during the experiment. Firstly, this is important to place the ice exactly at the level of meniscus when recording the burette readings. The ice level must be perpendicular to the reading when recording the data to avoid parallax error. Other than that, titrate the fruit juice in the conical flask with the sodium hydroxide from the burette slowly while shaking the flask until the indicator color change. This helps in achieving an uniform mixture of the reactants and the reaction proceeds at a faster rate.
My name is Nazhan Akil. So now, we can conclude that fruit juice titration is a specific application of volumetric analysis known as titration, used to determine the concentration of acids, primarily citric acid in fruit juices. This method is employed to assess the acidity of fruit juices, which greatly influences their taste, preservation, and overall quality. The procedure involves diluting a measured volume of the fruit juice sample and adding a suitable indicator such as phenolphthalein or bromothymol blue. In this experiment, a standardized sodium hydroxide solution is slowly added from a burette to the sample while stirring continuously. The base reacts with the acid in the juice, resulting in a neutralization reaction. The indicator's color change indicates the end point of the titration, at which all the acid has been neutralized. The volume of sodium hydroxide solution used is recorded, allowing for the calculation of the acid concentration in the fruit juice. Fruit juice titration provides important information for quality control, product labeling and flavor assessment, ensuring consistent and accurate determination of acidity in fruit juices and contributing to their overall quality and consumer satisfaction. These are some references for our video. Thank you so much for watching our video. Have a good day.